Hello, I'm on. Sorry, I was getting my clock ready. So don't go over. Hello, everybody. Welcome. This is What's New in C# 11. The title of this talk that I submitted and the abstract that I submitted was mainly jokes about the parameter null checking feature of C# 11 because there was all this drama about it and lots of people saw it as the downfall of the language. And I was going to talk about that. Probably make fun of it a bit, but as you may have heard, that's been canned yeah. Well, see, I actually like this feature, but I'm not going to get into it. It is interesting, though, to still just talk very briefly about, well, my position is it wasn't the sign of the downfall of the language. Now it definitely isn't since it's not in, but actually the fact that it's been removed is almost like proof because the team actually did listen to all of the feedback and said, yeah, all right, fair enough. But there is still some, or one in particular feature that you might think is maybe a sign of the apocalypse. But it is a good reminder to everybody that if you have strong opinions one way or the other about any of the features that I'm showing or that are planned, C# is open source. You can provide feedback. If you don't want to do it on GitHub, Twitter works arguably better than GitHub. But so what we're actually going to do today is I'm just going to run through a bunch of the C# 11 features. I'm going to focus on the ones that you can use right now. If you get Visual Studio 2022 preview, that's all I'm using for demos. Everything's going to work. But there's like heaps of features. So I'm happy for this to be like as interactive as you like. If you have questions, yell out. If I'm waffling on and you want to get on to the next feature, yell that out too. We can somehow form a democracy, I don't know. We'll work it out. So the first feature we're going to talk about is raw string literals. And so I have one slide per feature, and then I'm just going to Visual Studio it up. Basically, raw string literals. So the first two strings on the screen there is the, I guess, old way of doing things that you're all used to. And essentially, you can see that we have to escape quotes. Strings are delimited by quotes. Therefore, if you want to quote in your string, you have to tell the compiler, this is not the end of a string. Great. So the raw string literal is on the bottom. And a raw string literal has one sort of headline feature. You will never have to escape any character. That's the broad thing. So let's talk about it a bit. Actually, let's go over to here. Oops, to here. Okay, so raw string literals, this little tool here, you put in some code and then you put in two different alternate versions of the code and it shows you a diff of what they look like once they're decompiled. So if I scroll down here, and we can see this is just to prove that it works. The only difference here is the exclamation mark. So raw string literals, having this string over 2 lines is exactly the same as having this string over 2 lines. It's exactly the same as having this string with a new line in the middle. There's nothing special about how they output. The whole idea is you just don't have to escape anything. So if I come over to Visual Studio, so a raw string literal is 3 talking marks, which is a lot, I agree. Actually, you know what? It doesn't actually, it can just be on 1 line. That's totally fine. If I want to go, you know, hello, like that. That looks a bit weird because it's 4 now, but there we go. And so the idea is I can just put in my quotes. As you can see there, I can put in new lines if I make it a multi-line raw string literal, which means the first line has to start on the next line, which is a bit weird, but hopefully it'll all make sense in a second. I can put in tab characters. I can put in all the normal stuff that you would have to escape. I don't have to escape. This is the feature. The thing that's interesting about them is you'll notice that everything on this line, if I just go, make some more lines. Everything on these subsequent lines here is indented by 4 spaces. One of the other features of raw string literals is it allows you to make your code look a bit nicer, right? If this was a verbatim string, I would have to go like this. I can go hello. I have to escape my talking marks. And I have to start putting the rest of this string at character 0, right? And so, I mean, that's not a big deal, but if you've got code that's indented already because of braces and whatever, it kind of looks a bit funny. I find this all the time in unit tests, where I'm testing a bunch of data, and I'm over here in my test, and as soon as I want a multi-line string, I'm now back over here. It's weird. So raw string literals sort of fix that. And actually, if you look, I'll zoom in, see that vertical line there in Visual Studio? What that is doing, whoa, that's showing you where the sort of logical start of each line is, not the actual start. And if I just move this, sorry, magnifier. If I move this end quotes backwards and forwards, you can see that line move, right? So that's the end quotes define where this string logically starts. Everything before that is ignored. And so again, that's really cool as well for like unit testing. The other cool thing about this for unit testing is, let's say, for example, you were testing a web service, and you might want to have some JSON. So the really cool thing about this, I love, is I can put in my test data, which is absolutely not valid. And the best thing about this is I can copy this test data and I can paste it into Postman and I can see if my thing works. Or I can get a result from Postman and paste it into my code as an expected output, and I don't have to do any more work, which is like, saves you hours per day. So that's really cool. And you can see I don't have to escape my quotes, which is great. The question then becomes, well, how do I make this, like often what I want to do here, I don't want to hard code this name, I want this to be some interpolation. So how do I do that? And so the way I do that is I use a $ to get an interpolated raw string, right? Makes sense. But remember I said you don't have to escape anything, right? See, my code has errors here, because these braces are now confusing. In normal interpolated strings, we escape them with double braces. With raw strings, you don't have to escape anything. So this is where we get a little bit crazy. If we put $2, we're now telling the compiler that an interpolation uses 2 braces. So now I have a valid thing, other than I haven't defined name, but I trust you can understand that. I haven't escaped any characters from my data. You can kind of say maybe I've escaped my interpolation holes, but you can argue that if you want. So the reason this gets a bit crazy is, how do we deal with quotes? Say I want 3 quotes in my string, right? I want this to be this, even though it's not valid JSON. Oh no, I have a mistake. How do we fix this? Well, you make 4, which, actually, hang on. Oh, hang on. See, this is, the editor has helped me here by, there we go. So now, my raw string has 4 double quotes, which means I can use 1, 2, or 3 double quotes in my string without it. And yes, you can just keep going. And eventually the editor gives up trying to help you, but whoops, whoa, hang on. Yay, this is valid C#. And in fact, so is this. And I can just keep going. And I can just do this for an hour, and that's part of my talk. So, hopefully you won't do this. I'm kind of surprised there isn't more feedback online about, oh no, this is the downfall of the language, because it can get silly, but I suspect that most people, there'll be $1, maybe 2, there'll be 3 quotes, we'll all live happily ever after. And that's basically raw string literals. There's not much to them. And in fact, as far as, like you can see here, as far as the decompilation goes, like it's just a string. There's nothing really special. The one thing you can't do with them is, so there's no such thing as a verbatim raw string because they are already raw, right? They're already verbatim, so the @ sign is not valid, but apart from that, they're just strings. So yeah, they're kind of cool. In fact, the biggest downside to raw string literals and why maybe you don't want to adopt them everywhere is that like GitHub's code highlighting doesn't know about them yet. So cool. List patterns. Okay, who likes patterns? Does anyone like patterns? I love patterns. Who's an introvert and doesn't want to raise their hand? Cool. So list patterns are cool. List patterns, sorry, I should talk about this. List patterns are, like all other patterns, mainly a way to simplify code checks. So if we imagine X, in this case, is an int array, I guess, I can check, is there at least 3 items in the list? Does it start with 1? Does it end with 10? I can do that in that first line of code, or I can do that in that second line of code. And if you've never seen a pattern before, if you've never seen a list pattern before, yes, it looks weird. Don't worry, I will explain. So the way this works is, let me get rid of all of this. Let me pretend we get an int array. So the way this works is essentially what we're doing is we're saying, if my array looks like this. So if my array X has 3 elements, first one's 1, second one's 2, third one's 3. That syntax is hopefully not too crazy, right? We can understand it, that's all cool. And that's essentially a list pattern, right? That's not the simplest list pattern, because I guess the simplest will be if there's 1 element. But that's what this is doing. Where things get maybe a bit more confusing, though, is each one of these things in my list pattern is itself, or can be, another pattern. So I can say, this should be not null. Now, it doesn't make sense for ints, but we'll ignore that, right? So now this is saying, hey, here's an array of, well, I guess I can make this, we can shut the compiler up. Is my array 3 elements long? First one's 2, first one's 1, second one's 2, third one, I don't care what it is, as long as it's not null. That might be useful. If I make this, let's make this a string array. So I can do something like A and Z. But what if I want any, why didn't that work? Oh, because it's a string array, not a char array. Right, sorry. So that's cool. What if I don't know how long I want my array to be? Well, that's where I can use ... which is the range syntax, if you haven't seen it before, from C# 10, 9, something. And what this says is there at least 2 elements in my array, the first one being A, the last one being Z. Could be any number in the middle, they could be anything. And in fact, what I can do, I can say, is there any number of elements in the middle of the A and the Z? Also, give me them into this variable called subarray. And you can see that's a char array. So I can pull out bits of my array and work with them as well as checking boundaries. One thing that I quite like with this, because it kind of gets a bit funny to talk about this in the abstract sense. Let me just write a little sample here. I've actually used this in anger, and I think it's quite effective. So if I split this path into elements, right? List patterns is a really cool way to sort of analyze the path and maybe pull stuff out of it. So for example, I don't care where my software is installed, so I'm going to start with a ... but it has to be installed in a directory called Wengier, and then from there I want to pull out the components and I don't know. Let's do that, right? What this is saying is, hey, is the path given to me, is it a path I recognize, but I don't care how it starts with, which is kind of nice. And then, am I in the component subfolder? And then have I been given the path to a component? And if so, what is the name of that component? And this var actually is probably what you want to do is do something like this to say it shouldn't be null, just in case, although I know, string split's not going to put in any nulls, but you might want to. So you can sort of do some like parsing as well as your checks, which is interesting. And then now I can just, party on name, it's just a string, I can do what I want. So it gets kind of cool. If we go into SharpLab, can have a look at how this works. Let's go with a string. So with a string, which you can sort of treat as a char array, so I can do my A, ... Z. And so we can see on the right what the compiler is actually doing. So the first thing it's doing is a length check, right? We've specified 2 elements, so we know it has to be at least 2. Notice it's greater than or equal to 2, not 3, so the ... could be empty, right? And then we're checking if it starts with A, starts with it. If we wanted to make it so that, hey, it has to have at least one thing between the A and the Z, we can do that by adding another pattern, in this case the discard pattern, because I don't want to actually capture that value. I just want to make sure there's at least one thing. So now our length check is for 3. And then, I can do all sorts of things. If I make this a list of strings, then I make these into strings. Whoops.
Declaration.
Yep, thank you. There we go. So I can do things like, well, this is a string, so I want to make sure the length is greater than 0. So this is a property pattern inside a list pattern. And you can see down here, so now, whoops, the compiler is checking the count property instead of the length property, so it knows what's going on. it's pulling out the bits of the string, it's checking them for length, like it, you know. This is saving you that code, essentially. So it can be a bit confusing at first, but once you get used to patterns, they can be really powerful. They can also be really confusing, and it's definitely a use sparingly type thing.
What's the scope of the var?
So the scope of the var is interesting. If I do, so we should be able to see it here. No, I probably need to use it. Hang on. The compiler's being too smart. So one of the reasons this has gotos in it, which obviously you would never write because you'd be, you know, abused on Twitter. One of the reasons for this is to capture that variable. So we can see here, this text2 is essentially my x that I defined there, and it's defined at the very top. So I can, I think I can use it out here as well. Or am I inside the if? No, okay, so it's only inside the if. Okay, that's interesting. So for out statements, that's not how that works, which is interesting. But yeah, so inside here is normally where you'd use it, which actually that does make sense, because then you can do it without conflicting names. But yeah, all of that stuff, you know, like, for example, like if I change this to object, I can make this string. Yeah, length doesn't work now. All of the different types of patterns all work within there, so type patterns and property patterns and whatever. Yeah. Cool, that's list patterns. Any? Cool? Okay. UTF-8 string literals. I'm probably not going to bother demoing this unless someone wants me to, because this is relatively niche, but you can do it now because it's in VS. What this is, this used to be a little bit more like common a scenario, but then there was a compiler change, or language change a couple of weeks ago. So what this is a way of specifying binary data, but it looks nicer. It's called UTF-8 string literals, but my recommendation is not to think of it as a string literal, because it's not. And actually, I will demo that because it's kind of interesting. So the way you do this is you just use the U8 suffix on a string. And that S variable there is binary data that represents the UTF-8 encoding of that string, which is 65, 66, 67, if anyone knows ASCII. The interesting thing about this is that if I mouse over var, and if you can read the relatively small text, it's not a string. Don't think of this as a string. You can't use string operations on it. It's a read-only span. The reason it's a read-only span is performance. It used to be, in the first versions of this feature, that would have been a byte array, and that's maybe a bit more common that you might have a byte array in your code, and then it might be nicer to replace it with a UTF-8 string. This is sort of a language request that comes from ASP.NET, because all of their headers, like HTTP headers, when they're parsing them, etc., they check, does this start with HTTP 1 or 2 or whatever it is. All of that is UTF-8 data, and for performance, they don't treat it as strings, they treat it as byte arrays, as binary data. So they do lots of comparisons for, is this a known, essentially is this a known string, but it's actually, is this a known byte array? And so then the code doesn't look very nice because it's got lots of magic numbers that, with a comment that says, trust me, this is the word, whatever. So this is just a way of encoding binary data. It is not a string. You can get back to a byte array by calling toArray on the read-only span. The way this works is actually really interesting if we jump into SharpLab. Well, it's interesting if you like that sort of thing. So the way your string actually gets encoded directly into the DLL, and this private static read-only int blah, 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 that is then not supported, it is a read-only span over the memory from your actual DLL. So when we say this is for perf, like there is no allocations here at all. This is reading an array of memory that is directly coming from your assembly, which is kind of cool, just not in everybody's domain of what their program has to do. Whoa, don't know what happened there. Okay. So yeah, that's UTF-8 raw string literals. Sorry. There is also UTF-8 raw string literals. There's not much to them. if you need them, they're good. If you don't, you'll probably never see them. All right, required members. This is probably the one that I would imagine most of you will use and maybe will be good. So I'll probably talk about this a bit more than the rest. I think 20 minutes in those, that's right. Required members. Okay, so required members is you can now mark a member as required, essentially. So in the old days, if we wanted to define a class called person with a first name, and we had to require people to provide a first name, we'd have to use a constructor. It's not a huge price to pay, but you have to. Let me just create that class. So constructors, you know, they're not a bad thing, but over the years, C# has sort of been moving away, well, not away from constructors, but providing other ways to do these things. So, for example, we have init-only properties now. So I can say this first name, it can only be set when you're creating this object. It can't be set afterwards, right? It's immutable. We also have nullable. So I can say that this middle name is essentially optional. You can leave it unset. And string last name. And if you've ever done this, you'll probably be familiar with these warnings I've got here, which is nullable analysis saying, hey, you said first name couldn't be null, but you haven't provided a value for it. You've got to fix that, right? Because otherwise someone can go new person up here. And if I go p.firstname.toString, I'm going to get a null reference exception. If I did that on middle name, well, I still could get a null reference exception, but the compiler's at least warning me, hey, this could be null. With first name, I've said it's not null, but I haven't done anything about actually making it not null. So in the old days, what we used to do is we'd probably do that, maybe, to say, yeah, just shut up, compiler. That's what I do. And that's cool. Like, if you've got this data coming from, you know, JSON serialization and you know that that first name is definitely always going to be there, then, you know, go for it. It's your code. Compiler is only suggesting. But it's a bit annoying. So what the required property does, the way I like to think about it is it shifts the blame. You'll notice the squiggle has gone from first name in my class, but it's now on person in my construction of the person. Because rather than the class author having to supply a first name, the required keyword is said, whoever creates this person, they have to provide a first name. And so if I do that if I do that here, my errors go away. I'm now creating most of them. I'm now creating a person. I'm providing the first name, so the compiler's happy with my constructor use. The property has required, which means the compiler knows that whoever creates this will have to supply a first name. We're all good. Last name, I can do the same thing. This now back to errors. We have an error. It's specific to last name because it knows I'm not setting last name. So this, to me, kind of rounds out that nullable, I mean, not the nullable feature, but, you know, that way that you define classes with, I want to use nullability, I want to use object initializers or records or whatever, you know, the newer style of C# maybe, but I don't want to have to fight the compiler. I can still use a constructor, of course. So if I create a constructor that takes in these two names, for example, first name equals first, equals last. So I can still create a constructor, and that looks cool, but something interesting, well, sorry, that's just saying there's no constructor, so I need another constructor. There we go. So this is all cool and there's no errors, but something interesting happens here if we try to use this constructor. So if I create another person, whoops, we get an error. And this is a bit weird. This is the gotcha with required properties. And what this says is you haven't provided a value for first name and last name. And that's a bit weird. The reason is essentially, as with nullable analysis, and most things in general, the compiler doesn't do deep introspection of your code. So if you like, you know, draw a horizontal line in your mind here at line 11, the compiler is not going to look into that constructor I'm calling and see what it does, because that could be disastrous, right? That could call another method, it could use reflection, it could do whatever it does. It could hit a database. The compiler can't do that. So this is basically the honor system. the way this works, or the way we can make this work, is I can add an attribute to this constructor called sets required members, which just tells the compiler, if anyone calls this constructor, don't error. It doesn't do any checks, right? If I remove this, still no errors. Everyone's happy, except for, oh, actually, maybe not. Oh, there you go. Oh, right, so now I'm back to my nullable warning, yeah. Okay, well, so if we didn't have the nullable, right, the required members part of the compiler would not complain about that, which is a bit weird. There was a question I saw on somewhere, a Discord last night, about this, which is, why do we need this if we have nullable, right? I'm said here that middle name is not required. I've said that first name is required by virtue of making them not null. If I create the constructor, why do we need this? Essentially the answer, or my answer, I don't know about any official answers, is A, you might not like to use constructors. They sometimes get annoying. You can have lots and lots of properties. Sometimes that's a pain. But B, you have to think about this feature completely separately from nullability. So to me, it closes a gap with nullability, but there is absolutely nothing wrong with me saying that this middle name is required. Just because it's not nullable doesn't mean I can't make it required. And I can totally just go here and I can say, yeah, it's null. That's fine. If null is a valid value, that's one thing. And if someone has to specify a value for middle name, that's a completely separate thing. That value I specify could be null. So again, maybe for your code, that's not relevant. And if you trust where your data is coming from, you don't need to worry. But that's the whole story. Any questions? Yes, Ben.
So you don't need nullability enabled for the required squigglies to come?
So they're completely separate features. So if I remove this, so if I remove this and make middle name non-null, right? This is now giving me nullability squigglies. If I disable nullability, they go away. But all my required checks would still be in place. So this is still complaining about first name. So they're completely separate features. And this is generally, there's a few features of C# where this sort of comes out, where if you look at these three features together, one of them is not required. But essentially you can't look at them together, right? The compiler team has to make each feature a constrained thing. Is there any more questions? Yes?
Is that solely a compile time feature? Like if I'm throwing some JSON at an object, it's not going to be checking the required
Good question.
runtime?
Yeah. Oops, I just copied instead of pasted. Yes, so this is, so much like nullability, this is just a compile time feature. Oh, okay, I have to fake. SharpLab is on .NET 6, and this requires .NET 7, so I just have to fake some .NET 7 types. Won't be a second. To answer your question, yeah, so this is just compile time. So JSON deserialization, reflection, any of those things, they'll happily work. But then that's true of nullable as well, right? You can have a nullable property, set it null via reflection, no worries. What am I doing? Creating an attribute. So it is compile time only, which is something to sort of be aware of. You do need to know where your data is coming from. The only thing that, well, the only other thing that's interesting there is if you've got a generic method and you use the new constraint, that one, because like that's not runtime, that's compile time. So the compiler enforces that in the sense that if you have any required properties, then your class can't conform to that new constraint. So depending on how you're doing reflection or whatever, it could be okay, right? If you've got a generic method that uses activator.createInstance, you probably can't call that generic method anymore. But you can call activator.createInstance if you try hard enough. Let me just create this one more attribute and I can show you how this works. And this one needs a constructor.
Yes, on the compiler services.
What? Oh, thank you. We have .NET 7, everybody. You thought making a framework was hard. So what can we see here? So there's a couple of things since we're talking about reflection anyway, any class that has any required members will have this required member attribute. Any required member, obviously, will have this required member attribute. The constructor gets this compiler features required and an obsolete attribute. This is a bit weird and in the weeds of compilers, which maybe you don't care about, but here we go. This is essentially so old compilers will not let you create an instance of this class. So the obsolete attribute causes an old compiler to error because it's got a property on the end here that says error true. So if you use this from an old project, you try to call a library that has required members, your compiler will error and say, hey, I don't know what this means, something could go wrong. The compiler features required is then the formalization of doing that. Instead of using the obsolete method, the compiler's going to move to this new attribute, but the compiler's only going to move to that, so all of the old compilers don't support it yet, so now we're in this transition phase where we do both. But essentially, that's all there is to it, really. You get this little attribute, and that's all there is. So if you're referencing a NuGet package and they have required members, the compiler will look at these attributes, and all the same things will work. It's compiler only, not runtime, but that doesn't mean it's limited just to source code, if that makes sense. And I must be talking fast because we're only 31 minutes in. Static abstract interface members. This one's interesting because this one is a C# language feature that is somewhat, I don't know whether it's relevant, but it's somewhat small, but there's a whole runtime element to this as well. So what this is basically what it says on the tin, which is interfaces can now have static abstract methods. Previously, interfaces, well, the abstract is kind of redundant, but unfortunately because of previous C# language versions, you have to have it, because you could always have static members on interfaces. But essentially, I have an interface here called iAnimal. It says anyone who implements iAnimal has to have a property called canWalk. That's not exciting, but in this case, the property is static. Cool. The way this works, or where you want to use this, the way this makes sense, is in generic types. So my method at the bottom there is a generic type, takes in a t, we don't know what t is, but we say that t has to be, at the very least, it has to be an iAnimal. And so once we know that, we can now call this canWalk property on t, whatever t is, right? Might be a dog, might be a cat, whatever. We can call it on t. So normally you would need to do dog.canWalk, cat.canWalk. Obviously, in order to type out the word dog, you need to know what type it is. If you have a generic method, you don't know what type it is. So that's the feature. And that may or may not be useful to you. There's lots of advantages to this. It's pretty common in interfaces to have properties that sort of represent data about the type, like this canWalk, for example, but because it's not an interface, you end up having to define it as an instance property, so then your generic method has to create an instance of it or get given one so that it can call these things. So if you can do that statically, then that's a little bit of a perf gain. You might not create so many objects and things. But where this is going to have the biggest impact on everybody is that the runtime, .NET 7, has adopted this, and this is the foundation of the new generic math feature that you might have heard about, which I'm now going to talk about, even though it's not a C# feature. I don't care. And basically, what are we going to do? Let's write an add method. So we're going to add two numbers together. We're going to return a plus b. Great. I don't even know what that is. Oh, it's not called. Yeah, well, I'm fixing that. There we go. We're adding two numbers together. Great. Wonderful. This is cool. We can all write this code, but it's not very flexible because I can't add 2 to 3.2. And so I can go in here and I can make these all decimals. And now this code compiles. Oh, actually, it probably doesn't because I probably need to tell it it's a decimal. So that's a bit annoying. I guess if I made them floats, then that would be OK, maybe? Still need to put an F? OK, I'll put an F. Anyway, this would then presumably, the answer would be 5.2000001. But so this is, it's a bit annoying, right? I'm sort of limited. What I really want to do is run an add method. I don't actually care about data types. You might have your own custom integer type. Maybe you're fancy. So what we can do is we can make this generic. This is why generics were invented. Whoa, keyboard use is hard. So I can make this generic, this all works, except this call doesn't work anymore because how do we add two random types together? Don't know. Fortunately, it turns out that plus in C# is not really a plus, it's actually a method call. And it's a method call called op_addition, and it turns out it's static. The main reason this whole language feature exists is because, well, a man named Tanner wanted to be able to call static methods. So if I say, hey, t has to be a number, my addition operator now works. Now I have a generic add method. It's that easy, folks. This is all because this iNumber defines an operator, which happens to be a static method, that adds two numbers together. The interesting thing is when we go to look at iNumber. So iNumber defines a bunch of stuff, which is cool. But most importantly, it implements a bunch of interfaces. It actually implements like a whole lot of interfaces, like really a lot. And this is cool. There's a little quirk here with all of these ones the runtime defines, which is all of the T's have to be an implementation of itself with itself as the generic. It gets a bit funny, but the compiler works it out, so who cares? That's the only thing you sometimes is like, what the? Anyway. But this is cool, and if you have some time, in your free time, looking through this is interesting. There's some interesting little things here. So in particular, if we go to addition, I believe. Yeah. So iNumber implements addition operators. And guess what? Here's our static abstract method, right? This is the plus operator that I'm calling from my generic method. The reason this works is I'm essentially, it doesn't look like this in C#, but I'm kind of doing this. Yeah. Well, as I say, it doesn't work in C#. But that's what I'm doing, right? This is just a static method call, this little thing here. So there's a bunch of these interfaces now in the runtime that enable all this support, and that's cool. We can do things like, hands up in the room if you've ever re-implemented math. Hello, Aaron. So we can do things like, t dot identity? No, 0. This is what 0 is, right? And I can even, I can create a class here, and I can say, yeah, I implement iNumber. And I can go public static goo 0 equals, I don't know. There you go, there's 0. Like, you can implement these things as well if you want. There's a lot to implement, obviously, in this. But so it does get interesting. This does actually get useful to, obviously, math itself is useful, as much as I hate it. But there's more here that's actually useful. So one I quite like is iParsable. iParsable of t means I can now call on either of these A or B methods, I can call parse or try, sorry, not on t, I can call parse or try-parse. Now this to me is really useful, right? This is saying, I don't care what type you've given me, I'm going to call try-parse and convert from a string to whatever you are. I could see lots of ways that could be useful. In fact, I probably would have in the past created my own sort of form of this where I had an instance method that did this work and it was just this wasted, why do I need an object to do this? So there's a bunch of goodness in .NET now. If I can get back to iNumber, probably going to type it in. So yeah, there's a bunch of goodness in .NET that now uses this. So formattable, you can formattable's old. There's span formattable, span parsable are cool. So if you've got spans, you want to save some memory, you can now use them generically. Addition, multiplication, comparison, all these things. All of this stuff is enabled by static abstract members, but obviously is part of .NET 7. But you can then use any part of this to maybe light up some new things in your code. The other thing this is really useful for, and I don't know if there's an existing interface for this, but one thing I quite like is I can go interface async factory, and I can go static abstract. What is it? Sorry, it's going to be a t, and I've got to do where t is an async factory of t. I think I'm going to leave that off. And maybe the compiler error will tell me. So create async. Oh, I guess this is a task. That's a really useful interface because we don't have async constructors in C#. But now we can call await create on any old type that you just tag with this iasync factory, and away we go. That's really cool, and possibly might even mean that we'll never get async constructors because we kind of don't need them. As I say, I don't think there's anything inbuilt in this in .NET, but I could totally see if .NET 8 or 9 or whatever gets some iasync whatever factory that becomes popular, that, you know, that might be how we do all these things. So this one's the feature that I could see everyone using the most, but it's going to be probably highly specific how you use it, right, based on your domain and what you do. There's a bunch of potentially memory savings you could get if you've got this pattern where you use instance members for what really should be static because you couldn't do static. And then there's a bunch of other stuff like, you know, factories and whatever that you can get from that. Any other questions? I think that's my last, yeah. So that was the last feature that works right now. And if you want to play with any of that, go get VS 2022 preview. Go nuts. The only thing you need to do is bring up the project file. So target framework 7 for required properties for static, etc. Static abstract. Oh, well, not for static abstracts, but for math, although possibly static abstracts as well. And then lang version preview. And then I think there's another, no, maybe it's just lang version. I think there's another, I think you have to opt into another preview thing for static math, but that might have been removed. Sorry, no, that was only for .NET 6. A lot of this stuff actually came out in preview in .NET 6 and to get feedback so that it can come out properly in .NET 7. So yeah, .NET 7 you're fine. But yeah, so you can go play with any of that. These things are all new features of C#11 that I can't demo easily, but I'm happy to talk about them, or any one of them, or any of the other stuff I've talked about. So we're about 40 minutes. Does anyone have any questions? Or I'm just going to, I mean, I could do this all day, literally. Nope? OK, cool. And some of these are really, tiny. New lines in interpolation nulls. Actually, I think that one is in VS now. This one is really, so I can go hello name. I guess I better need a name. I can now do this. There you go. That's a new line in an interpolation hold. So some of these are tiny. This is just one of those things. I think this was the guy who was implementing raw string literals was surprised you couldn't do this, and it was like, does anyone mind if I comment out this little, thing? So that's cool. Top level statement attributes. Actually, I don't know if that's going ahead. The idea here is, let me bring up Sharp Lab. So if top level statements, which you may or may not be familiar with, is the whole, I don't need a class, I don't need a thing, I do need a using statement. They synthesize a main method. So there is still a main method, there is still a program class, you just didn't have to write it. And so you couldn't ever write attributes on that main method. What this feature is that you can go basically main, whatever, and it will output an attribute. As I say, this isn't implemented yet. I think this one actually might not make it because I think it got into some really tricky compiler-specific things. That's pretty much just for WinForms, WPF type stuff where you need to say, I want to be a single-threaded apartment and you can't use new stuff. Delegate caching for static methods, that one's a good one. So now I need to remember how to demo this. We go void m and we take an action. Yep. And then we have another method here. And then we call m. And we pass in a lambda that calls n. And whoops, or we just do that. I think that's right. Yeah, no, it's not right. Okay, well actually, no, so this is the old code. I need to make these methods static, and maybe that means I can't use top level. Anyway, see these two lines here, right? This is my call of m with the lambda at the top and not with the lambda at the bottom. This looks like a complete mess because these type names are fake and you can't type them. But what this is doing is saying, hey, use this field, which is this field, Or if it's null, initialize the field and then use it. And so this is a form of caching that happens with lambdas. And it happens everywhere, and it's for performance. It doesn't happen if you just use the method name directly, and so that means it's got worse performance. But it looks a lot nicer. And so a lot of people do it, and then a lot of people come and go, I can improve your performance. Well, it needed a spec change to allow this, but essentially the compiler now makes these two lines the same. So if you want the neat format of passing methods as though they were lambdas, you now can. It is actually quite nice. Generic attributes, relatively straightforward. So if you've got an attribute where you have to pass in type of blah, you don't need to do type of anymore. You can make it generic. That's all. As far as I know, there aren't any attributes in .NET that use this yet, but one day there will be. Name of parameter. So you couldn't previously do this. Name of A. You couldn't previously do this. No. Because it would say, I don't know what A is because it's outside the method and A is inside the method. You now can. I told you these aren't very exciting. Pattern matching on read-only span. This is one of those ones where, again, if you have read-only spans of chars, you will love this because you don't have to convert them to strings anymore. In fact, I'm not even going to demo it. If you don't have read-only spans of char, don't worry about it. Relaxed ordering of ref and partial. I couldn't tell you what the order of ref and partial was, but I now know that it's relaxed. I think he used to do partial ref, but for some reason people like saying ref partial. I don't know why. Semi-auto properties is an interesting one, actually. That one's worth digging into. And I would have done this as part of required properties, but it doesn't work yet, right? There's rumors that this might not make it in as well. Because I think even, yeah, there's a branch here, but I don't know how up to date it is. What semi-auto properties are? So I've got my class person, right? And I can make my required string name, which actually probably won't work because this branch doesn't have the required stuff in it. Or SharpLabs just died. We're just going to go back to main. So, I can't use required. Okay. We have our property we're going to pretend is required. Great. So we've said it's not null. We've said you have to set it, but we can't say anything else about it, right? We can't validate the property. What we want to do is we want to validate it. And I can do that by putting in a body for this. Why did that brace go over there? I can put in a body over here, and I can say if value, dot length is less than 3, and I can throw an exception or something. And I can go, well, now what do? Now I need somewhere to store this name. So now I need a field. And so now I need to provide a get as well. So adding this little bit of validation has caused me to have to write and expand all my properties out, which is kind of annoying. So what semi-auto properties means is, is I now have this magic keyword called field. And so what this says is the compiler is going to do everything it does for normal auto properties. In fact, I'm just going to, hopefully you can remember what that looked like. No, what? Semicolon. So many brackets. Okay, so the compiler for a normal auto property generates a backing field, right? A getter and a setter. Great. So all this does is semi-auto properties means you can provide one of the two accesses. Well, actually, you can provide both as well. Still saves you defining a field. And instead of the field name, just use the field keyword. And that, if you like, is replaced with name, k, backing field, blah, blah, blah. So you can do validation. You could put it in the getter and do toUpper or something on it. So it doesn't matter how it's set, but everyone will read it as toUpper. It saves you a bit of code, but it actually, I think, is really good. I think that toUpper example is a good reason for why this is, right? To normally say, I want to expose this property as uppercase, but I want to allow anyone to set it. Well, you'd have to define a field. So then you go, well, if I do the toUpper on the set, great. Every time I read it, it'll be uppercase. And if someone reads the field, fine. But what if someone sets the field? Or if you do the toUpper on the get, that's fine, except nothing stops someone reading the field. So I kind of like that this just for constraining things to say, you have to use this property, but you can still provide logic. Dim for static members, It's just so weird. So does anyone use default interface members? Yeah, I didn't think so. It's pretty niche. And so then now we have static abstract interface members. And so now we also therefore have default implementation members for static abstract members, which is that you can provide a static abstract member, but you can provide a default implementation if the other class doesn't. I have no idea why you want to do this, but you might. It's kind of super niche, but there you go. Params span of t, that's a good one for performance, if you're into performance. So previously you could do, params int whatever, but that's all. You can now do a span of ints. So again, it doesn't work. Don't know why I'm in SharpLab. This is, a parameter array. Well, it's not an array. A parameter list, but directly on the memory of whatever it comes from. Which means A, it's less memory, but also it means it's a little bit more flexible, right? It doesn't have to be an array. It could be something else. So that's good for perf. I don't know why I've got ref fields there, but I do. But maybe the ref fields aren't new. Anyway, file types. File types are funny. So I'm just going to go to Visual Studio. Looks better. File types. If we have a class person, I can make this internal, which means only for this assembly, or I can make it public, which means for every other assembly. But what if I want to help a class to deal with people, or persons, but I don't want it to be seen by anyone else? So I can do file class, person helper. That class is only visible in this file, literally this file, which is kind of cool. You could do this before with nested classes, it was pretty common, but even nested classes, they then appear in IntelliSense sometimes when you don't want them, or you can have name conflicts. The name conflicts one is especially annoying, right? If you have a class helper in here, then its visibility is good, but you can't have any properties or methods or anything called helper anymore in this class because you've now got a conflict. So file scope classes, is an interesting one. There's also some math stuff, and as previously stated, I don't like math, so I'm not going to talk about these. But just to complete the list, unsigned right shift, yay. Checked operators is actually we might need to know about this. We maybe can't escape this. I don't know whether has anyone used checked and unchecked mode in the compiler? No. Again, it's pretty niche, but essentially, one mode, you will get exceptions if you do the wrong thing, and the other mode, numbers will just loop around back to 0. More like C behavior. It's always been in C#, but you couldn't define different operator behaviors under these conditions, which was a bit weird, so now you can. All of the math stuff uses checked operators, but I don't know if it'll leak out. The relaxed shift operator, I love they use the word relaxed. What this means is that shift operators, so left shift and right shift, previously they could only be used on ints. And now they can be used on any type you like. You can just define a shift operator. Which does mean you can now write cout less than string like we all used to do in C if you write the right operator and class. I'm sure someone will. It's probably Aaron. Numeric int pointer is... This one's arguably interesting, again, if you're a compiler nerd or a math nerd or a .NET nerd. So int pointer... there's new types in C#10 for native int and native unsigned int, which is fun because the only reason they're cool is because you get to say nint and then you say nuint, which you always end up writing as wrong. You get the end of it. Anyway. These types are mapped to int pointer and unsigned int pointer in previous versions of C#, but in .NET 7 and C# 11, they're now their own sort of, they're a direct representation of those types. They're not mapped to them, which just sounds weird and fruity, and don't worry, it doesn't have any effect. But what it does mean is this feature essentially unlocks the ability for the runtime team to create new data types that have no compromises without needing C# keywords. So for example, int is int 32, long is int 64. the runtime team can now create an int 128, and everyone can use it, and there won't be a neat keyword for it, like long, or whatever they would have called it, but everything will just work. So, and a lot of this is building up on this static interface, idea, obviously, because now we can do math on it, that sort of thing. So this numeric pointer stuff is the piece of that puzzle. It's very exciting. There is actually one more thing that I just realized I don't have on the list here, and I maybe can show you. Does anyone use structs? It's like 2 people, yeah. I don't, ever. I try to avoid them. I don't know how they work. So, is this going to work? Yeah. Previously, this code is invalid. You couldn't define a parameterless struct constructor. The compiler synthesized one for you because that's how fields work in structs. So if I go, int x equals 1, you can see that x equals 1 goes into the constructor. Right? The compiler had to synthesize this. Now you can actually define your own. If you don't use structs, again, you don't care. If you do use structs, that's cool. You can do normal things with them. The reason it's worth mentioning is you might see errors. So if I go s, x equals new s, and I think if I comment that out, anyway, there is coming, if there isn't already, a warning that will be on this. Oh, no, wait, maybe it's the other way around. Default. There is a warning coming that, oh, here we go. I think I got it. Nope. There's a warning coming if you do this. So what it means is there is now potentially a difference between what new s with no parameters used to do and what it will do now. Because it used to be that new s, a new struct, was exactly the same as defaults, right? Created a new empty instance. Because the developer of that struct can now provide a constructor, that equivalency isn't true anymore. The code's not going to do anything weird. It still does what the developer intended, but it could arguably change meaning. So I think the compiler team, if they haven't already, they were talking about a warning. So if you do have code that uses the new keyword to create an empty struct, you might get a warning that says, hey, this could change behavior. Just so you know, that's what it's about. And you can either change it to default and keep your same behavior, or you can leave it because you're doing what the compiler, what the struct author intended. That's it. That's C# 11, I think. That's all of it. Hopefully they all get in. Otherwise, maybe not. What is it? It's June. We got to November. Should be fine. Any questions? We have 3 minutes. Or you can go get a coffee or lunch. Go get lunch. Enjoy.